Hey folks, Kevin here. Well, it's March 22nd, 2019. I'm out in the North Lower Workshop area, and this is a continuation of wiring up the outlets in the workshop. The last video I talked about appropriately securing the Romex wires feeding into the non-metallic or plastic boxes, the receptacles. These are all at 4 foot off the ground, so it's nice and easy for us to work at in a workshop to have access to the power supply that we may need. The protective outer sheathing on the Romex wire is extended at least a quarter inch, a half inch inside of each of the boxes, and the wires are secured with cross staples within 8 inches of the box, within an 8-inch run of the Romex wire. And we covered that in the last video. And today what I want to talk about is what I'm doing as far as wiring up the electrical outlets. So I guess the first thing, if I let Timmy get by here, is being able to recognize the visual difference between a 15 amp and a 20 amp outlet. So on the right side of the screen, on my left side, in this hand here, is a 15 amp outlet, and this is a 20 amp. And you can see that one of the up and down tabs here actually has a crossbar, makes it look like a little bit of a T as a result. And therefore, this is a 15 amp requiring a 15 amp breaker and 14-2 wire. Whereas a 20 amp breaker, a 20 amp receptacle needs 12-2 wire and a corresponding 20 amp breaker as well. And we'll go over breakers in another video with arc fault breakers, ground fault breakers, and that sort of thing. So in the workshop, and do I have one of these? And so this is also another 20 amp outlet, but this is a decor, just a different style. Many homes have these in them now. These are a little bit less expensive, so those are what's going in the workshop. So that's it as far as we're using 20 amp outlets and breakers in the workshop, because I never know, how much power I'm going to need for any particular tool in any different location. And it's just much easier for me to just run all 12-2 wire around for these outlets and get these in bulk and get these wired up. Now, a couple of things I'll mention about these outlets. Now, there's 3 different color screws on these. There's 2 silver screws, which are for your common or white wires. So the silver appearing screws are for your white wires or common wire that's insulated, and then your black wires attach to the brass colored screws, and there's 2 screws for that, and your ground wire, which is just copper wire without an insulation on it, that goes to your green screw, and that's either at the top or the bottom on a slight angle on most of these outlets. Code requires only 1 wire attached to any screw on the outlet. So that's important, especially if you've got, let's say, you've got 3 different outlets, or you have power coming into your receptacle box, and you've got 2 more. You want to go out to an outlet that isn't run direct. You've got one up above and one going off to the side. Instead of running a whole bunch of extra wire, you could have 3 pieces of Romex going into the box. And one of them could be the line, the power coming into the receptacle, and the other 2 are going out to other boxes, and therefore you'd have 3 blacks, 3 whites, and 3 coppers. And although you have the option of hooking 2 whites, 1 each to each one of these screws, the additional white would have to be attached to another white, and that's where we get to talking about wire nuts and all. So for years, this is, and I just pulled this out of one of my old units, and so what this is this is the common wire, the white wire here, and it has a wire nut on it that's really tight. So the wires, in order to have just 1 white wire coming from one bit of Romex and another white wire feeding out to or 2 other white wires going to other Romexes, and this has to be a light switch system, so no common wires needed to go to switches. But they all had to be grouped together, so there's 4 white wires here twisted together with a wire nut on top of them. And that's really tough to manipulate and get to easily manipulate and get the wires into the plastic or metallic receptacle box. So over the years they've come up with other ways of connecting wires and all. So there are push-in connectors, and they're all different. So this is a 2-wire push-in connector, and this is a 4-wire push-in connector, and hopefully these are showing up. And these are really good. You can go ahead and take your wire and push it in, and you have to make sure that it goes all the way in. And you can't see that, I'm sure, in the camera, but the clear plastic here, you can actually see where the copper wire extends all the way to the end of it. And then once you push the wire in, you grab a hold of both ends and you make sure it's in there nice and secure. The thing I don't like about this type of push-in connector, but these are much better than the wire nuts, is that it's a little bit difficult to reuse them. And you sort of unscrew it off and pull at the same time, and it will come off. And it almost looks like threads cut into, threads cut into the copper wire, where it really gripped down with the little metallic tabs in there. And these work extremely well, but they're just a tiny bit bulky when we have a 4 connector or 5 connector there as well. And they come in multiple sizes. Well then, a company named Wago came up with these, with a different type of push-in connector, which have a lever on them that makes attaching the wires really easy and detaching the wires easy as well. So in order to, well, here's one right here. In order to insert a wire, you just lift up the tab. You take, and this is a pigtail, you take the wire, insert it all the way in, and it's clear in the back so you can see where the copper wire actually extends to, and then just push down the lever, give it a tug, and it's in there nice and secure. But if you want to take it out because you want to change out the receptacle, or you did something wrong and you're testing things, well, you can pull that out as well. So these lever type push-in connectors are fantastic. Now this is the second generation of the Wago lever push-in connectors, and I'll put a link to their connections on the Amazon. And this is a kit. Does it show from this side? So we got 5 push-in connectors, 2 push-in connectors, 3 push-in connectors, and I think that's it. And there's like 25 of each one, so you can get a kit if you're not doing big jobs like this. Or I buy them in bulk as well, and I just refill the kit if I'm just doing a small job. And in this job I'm using lots of 3 push-in connectors, because that will allow me to have 1 pigtail and the 2 wires that correspond. This is the hot wire, so it's a black wire. I'll have 2 of the black wires coming attached into these 2 slots as well. The beautiful thing about this is once you've got your pigtail in, you can bend it because the other 2 wires will hook into the other 2 slots, and it's really easy to manipulate. And the wire can twist and turn a little bit so you can get everything tucked in nice and neat, and you don't feel like you've pushed it and a little bit of the insulation is exposed. These are all the way in, and it's so easy to see. The other thing I love about this connector is, so when you're, let's say we're having some issues and we want to get out our voltage tester and all, well, there's a little tab spot in the front to test it, and there's a little tab spot in the back to test them. So these are absolutely fantastic for ease of use, compactability, ease of reusing, and testing. So I really think these get a big thumbs up. At least they're light years ahead of the wire nuts that I've been using for so many years. So I think I mentioned this. So Code requires only one wire being attached to a single screw. The screw can be twisted and bent like my ground screws are bent like this, and when you put that on, you've got to have the curl in the direction, so going clockwise. So on this side, the screw will tighten down and not separate that loop. So that's really important. If I put it on this way, which is backwards, then as I tighten the screw, and I won't do it, but as I tighten the screw, it can loosen up or make that connection less secure. So that's important. So now I could have, since there's two screws for the common wire and two screws for the black wire, if I only have one bit of Romex coming from the feed side and one going out to the next outlet, I could just go ahead and just use one of these three-way connector push-in connectors for the grounds. Because there's only one ground wire here, I'd go ahead and hook up a ground to here and use two additional, pretend this is copper. I just use two additional copper wires going in here, one from the feed side, one from the outside, and hook to this, because you cannot hook two wires to, you should not hook two wires to a single screw. So I could use the feed black wire going to one screw and the feed and the black wire going out to the next outlet to the next screw. But the thing that I don't like about it, it makes the manipulability of the outlet itself, of the receptacle, challenging, maneuvering it and tucking it into the box nicely. And it also makes it a challenge if I've got to, because I'll be pulling all these back out when I put the plywood up, or if I build a cabinet around it, I'm making some adjustments and I'll be bringing it out. And the fewer the wires that actually attach to the outlet itself, the easier it is to manage. And therefore, we use pigtails. And so a pigtail is about a 6-inch or 15 centimeter section of the corresponding wire. So this is a hot wire. So I'd strip off about a half an inch of insulation from each side, as I've done here, and a half inch is about 11 millimeters. So we'd strip the wire, the insulation off of the wire from each side, hook one into a three-way plug, do the same thing to the wires that are coming out of the electrical box, and cut them off at the right length, then strip them down, attach them to the corresponding push-in connectors, put the levers down, check them, make sure they're secure, secure the wires to a single wire. So this is a white wire, so it goes to the silver screw. I put them in behind the bar in the back, and that works extremely well. I just snug it down really securely, and that way I don't have to curl these, I just leave them straight. It's much easier if I've got to change something out in the future instead of trying to untwist the wire. So that's about it. The only additional thing I do, and the reason that I do this is just for a little added protection in case I didn't turn the right breaker off, I didn't test to make sure that the right breaker was off, or just giving you excuses here. But to reduce the chances of getting shocked, when I have one of these electrical outlets, receptacles, out of the box, so the wires are sticking out of the box a few inches, and I'm putting on drywall, or I'm putting up the plywood, or I'm manipulating it, building it into a cabinet, whatever it may be in the future. And when you're doing the drywall afterwards, you don't want to get the mud messing up all the holes in this, so you want to protect it some. So one of the things I do use is just use some black electrical tape, and I'll wrap that around after all the wiring is done. I'll wrap it around the entire conductive surface around the outer side here. So the plastic's covered, the brass screws are covered, the silver screws are covered, and the ground screw is covered. So there are these small tabs that you can still get to, which are connecting tabs that connect these two screws together on each side, which you can use your tester to reach into to test the outlet. But I cover it all up to reduce the chances of there being an incident where someone gets a shock. So that's about it. So what's going to follow now are some GoPro footage with my head cam on, showing the process as well. Hopefully this all makes sense. I'm not an electrician. None of these are hooked up to a panel yet. All of these electrical outlets are just, the wires are all run to the plastic boxes. If you're doing renovation work, make sure you've disconnected the power, you've turned off the breaker, you've pulled the breaker, you've tested it to make sure. Don't try this without doing it. I'm not a certified electrician or a professional electrician. I'm a homebody, do-it-yourself guy, just trying to share a little bit of what I think is best. I'll put a link below in the description to these Wago second generation push-in lever type electrical wire connectors, and I'll put a link to a book that I think is really a good resource for identifying what code requirements are. The code changes every few years, so this is a Black & Decker book that goes over the code between 2017 and 2022. I believe it's up to 2022. Really nice reference for checking all of these things and making sure you're meeting code if you want to cut the costs and get a lot of this work done yourself. So those ground wires are secured in there nice and neat. I can go ahead and gently fold that back in nice and neatly. Bring this wire down. Again, this pigtail is about 6 inches long. I'll prep this for being able to go around the green screw. And so, real easy to do this. I'll just slide this on. And then what I'll do is just give it a little snug behind here. So that loop is contained very well. Of course, I'm blocking all the light here. Nice and tight, that's all in there, beautiful. Okay. Half inch to 11 millimeters of insulation being removed. Alright, so we got our hot wire, the black wire. Insulation's been removed. Slide it in all the way. Make sure it's in all the way. Make sure it's in there nice and snug. Manipulate the next wire in. Make sure she's in all the way. And really tug on both of it. You turn it over and the copper wire is extended all the way down to the cap there. So that's beautiful. So now that one can get folded back in there as well. common or white wire. Insulation's already been removed from these two. 1/2 inch bare wire exposed, 11 millimeters. Push it all the way in, put the lever down. Same thing with the next wire, make sure it's all the way in. You can always, when you're first getting used to it, check them. You can see all the copper wires are all the way down. Hopefully that's showing up there. Right down to the end. It's one of the things I like about it. With the wires in there, you can manipulate these so easily. Move them into the locations that you want. Pull them back into the box as nice and neatly as you want. Now we just have to hook those pigtails up to the corresponding screws. So only one wire per screw. So that's in behind the plate here. So I do this in a couple of turns, and then I know that's in there so securely. Turn it over, black wire to the brass screw. And that one's a tad too long, so I'm about 3/4 of an inch long there. So I'm just going to take a little bit off, 1/2 inch or 11 millimeters. Slide it back in there, and that's fine. Just don't want a lot of insulation being exposed. And I'm pushing against the receptacle, against the wire, the pigtail, to make sure it stays in there as I'm getting to snug it. And the reason I give it like little half turns or quarter turns is that plate behind it, it's manipulating and flattening out that copper wire. And that's nice and snug right now. And I don't want these wires ever to back out, so I just make sure that when I just snug them down, because who knows, over the years they could vibrate out a little ways. Double check each one, make sure they're in there really well. I think that this is a really good idea if you have a conductive box, and a metallic box. That's important. You don't want to include your screws. It's quite cold out here, but it's just above freezing right now, so this tape is actually working out okay. And I just want to put 2 layers of the tape all the way around. And just run it underneath the screws. If it were warmer, I'd feel more secure with this tape really securing down there well. Now, since the wire, the pushing connectors are up above up there, I'll bend the wire here a little bit and bend all of these like this. Bring it into the box, push it in far enough, and I'm going to start the screws in with my drill. And push this all the way back, and I do not drive the screw all the way in. I want it loose because I can strip that plastic real easily. So now that's it.